Hi, IB Physics student. This is a video about the hardest multiple choice questions in the past paper from 2012 to 2017. So you may think this is a clickbaiting video, but I'll say no. Because when I say hardest, this is based on the difficulty index in the exam report over the years. And the difficulty index, you can see in the picture, it shows that this is how many percent of candidate that year answering the correct answer. And this all thanks to my dear colleague, Mr. Lam, for analyzing all these things in all chapters. So please give a round of applause to him. In the coming video, we'll go through each topic and I'll cover 2 to 4 MC questions in each topic. So when you see these icon here, please try to pause the video and try yourself before I try to explain the questions. Before we start, I want to challenge you. How many questions in the following you can get it correct? For HL, there will be a total of 36 questions. For SL, there will be a total of 24 questions. Even for myself, I don't think I can do it perfectly because some questions are just really tricky. So let me know in the comment below of how many questions you get it correct. Topic 1. The tricky part for this question is you have to realize that the volume is being measured and also the heights are being measured. The radius is actually the one that being calculated instead. So this is something that you have to pay attention in the similar question. So what you have to do is by looking at this equation given, you have to change it to R as a main term. So what we can have is V over pi times H equal to R square, and you can further simplify it by putting a square root on this side. So if you remember the equation that you can find from the data booklet for calculating the percentage error, then you should know that since V is giving you 10% and H is giving you 6% here, then you add these two up become 16%, and due to the square root here, you will have divide by 2 and therefore 8%. So the answer is actually D instead. Okay, topic 1, unit. So this is asking you about the unit for electrical energy, and I would say you can just take it as energy, which you can relate to simply the most fundamental definition of work done. So work done is force times distance in IB physics, and net force could be mass times acceleration. And from this equation, you can try to derive by thinking of M is actually kg, and A is actually meter per second square, and S distance is actually meter. So if you try to multiply all this, you get kg meter square per second square. So simply the answer is C. Okay, so this question, the main keywords are seeing the string are almost horizontal. So what you can imagine is this angle is really small, as in like maybe 1 degree. So what you can do is, if you try to think about the free body diagram, here you've got a tension, here you got another tension, and here of course you got weight. So what you can have is the tension itself. This is not a very good one. The tension itself with the horizontal and vertical component, you would have 1 degree here, and if I call this T, then this gonna be T cosine 1 degree, and this is T sine 1 degree. And you can help this to think about sine 1 degree is actually extremely small. So what you would have is since you need to have T sine 1 degree times 2, because you have the 2 tension here, so you have 2T sine 1 degree equal to the weight. So what you can see here is, since this is very small as probably like 0.00 something, it's like really close to 0. So what you would have is the tension has to be much greater than the weight itself. So the answer at the end would simply be D. The reason why that some people may get it wrong is because they just simply follow this equation without thinking of this equation F is talking about the average force. So the 20 Newton that you might find is not the correct answer because this is not the maximum force. The actual way that you should try to do is by thinking of the area here, which the area should equal to the impulse, which is mv minus mu, and you could also calculate it by using the idea of triangle F maximum times the delta t divided by 2. And so by doing so, you can be able to find the answer, which is 40. Okay, next question. To save some time, I already drew the diagram here and have done some basic steps. The main mistake that you might have made is the u and v here, they are referred as speed instead of velocity. So normally when we use the equations as you can see here, these are referred as vector. So therefore v and u are velocity. But since speed itself is a scalar, and when we try to calculate the change of the magnitude, then we should do plus here instead. And therefore you can see the answer is basically A. For the KE, I don't think there is much difficulties, as you should know that this does not equal to this simply. For this question, you need to have some imagination and visualization. So what happened is the box didn't start to move until the applied force exceeds 0.5 F. So what you can imagine is at the beginning, maybe you apply for 0.1 F, and there must be an opposing force which should be friction, that is also 0.1 F. And when you add increasing with the 0.2 F, then the friction also increase to 0.2 F, and etc. And all the way until you are now 0.5 F, and the friction also go to its limit, which is 0.5 F, then the box started to move. And since by definition of work done, it is the integration of force with respect to the distance, you only count when the box start to move with certain distance, and therefore the force you should use is starting from 0.5 F to 1 F. And the idea you can try to imagine is, since you should not use any integration in IB physics, you can simply think that it is like the average of the force that you apply here. And so what you can do is take it as 0.5 F multiply with the distance x, and that will be the answer, C. Topic 3. So quite often that some student may have chosen answer B because by thinking of the gradient of this graph V against T, then you may use ideal gas law, you try to rearrange it, you get this small n times R over P. And probably you feel so stressful in the exam, and then you simply just think this small n probably is the same as this big N. But you have to really pay attention to how the n are defined. Here, the n is talking about the total numbers of molecules. While in terms of the ideal gas law, the small n is talking about the how many mole are there, the number of mole of the ideal gas. And therefore, you can't just simply use this n to replace the big N. What you have to do is you can see by looking at the green parts that which is the next steps. So first of all, you should relate the small n with the total number of molecules, big N, over the Avogadro constant, Na. So you can change the small n into this, but you can still see that this is not any one of the options here, and therefore you have to further change it by looking at the last equation from the data booklet, which you can try to deduce that Kb equals to R over Na, and therefore you can try to change this into the Kb, and therefore the answer, of course not B, but the answer would then be C instead. Topic 3, next question. This question may sound quite confusing, but the first thing that you have to recall is the idea of internal energy in thermal, of course, in microscopic view is composed of KE and also PE. And when we talk about the fraction here of internal energy that is due to the molecular vibration, this is referring to KE actually. So the fraction actually that we are referring to basically is KE over the internal energy. And if that's a bit too difficult for you to think, what you can do is you can take KE as in the internal energy minus the PE instead. And that will give you 1 minus the PE over the internal. So by looking at this, probably is easier for you to think, because different state apparently will have different potential energy. As in for solid, they will have the lowest PE, and therefore if you want to put order of highest fraction, then you want to make this the smallest. That means the smallest PE should go first, and therefore solid should be the first one, and therefore it go with the order of solid, liquid, and gas. Next question. Actually, I find this question very disturbing. The reason is if you try to use this equation, pressure equal to force over area. The area is referring to the contacting area, which I try to draw here. And the force itself is a weight, which is given, and the area is a bit tricky, where you can try to use the geometry idea of the big circle minus the small circle. You'll find out at the end, you can have this expression. However, this expression cannot be found in any of the options here. So you have to think one more step by looking at the question where it said R is much greater than X. So what you can think about is, since R is much greater than X, then what happened is the X squared here will be much insignificant compared with the 2Rx here. If you can't really accept that or get convinced by this idea, what you can do is imagine R is say 1000 and X is like 1. And so what we have here is Rx in that case would then be 1000, like 1000 times 1, while X squared is simply 1. So if you try to look at the whole expression here, then this will be like 2000 minus 1. So it's probably similar to 2000. So what we could have at the end is basically we ignore the X squared because it's basically like 0. So the expression that we have here will be the answer A at the end. Next question, topic 4, waves. This question is quite tricky, I would say, and it's a little bit abstract. Because the question is asking you about the average speed of a point. So you have to clearly understand what it means by average speed and also what it means by a point on the waves. If you try to think about maybe trying to see this is lambda, and try to use a wave equation v equals f lambda, because whenever you talk about the velocity, you may relate to this, but this is not the question, the equation that we need for this question. If you truly understand what it means by average speed, this is the total distance that you travel divided by the total time that you take. So for a point that, let's say this point here on this wave, what happens is this point will go all the way back to this position. And so you can see the whole movement, the distance would be 4 times 2, because 4 is the whole amplitude. Not amplitude, but the twice of the amplitude. 2 because it moved back and forth. And so in a total, it will give you 8 cm. And since the time it gives you is 5 milliseconds, and therefore V would equal to 8 cm divided by 5 milliseconds. And therefore the answer, you can try to get it, is C. And so again, nothing to do with the wave equation. The wave equation V that we are talking about is talking about how fast the wave traveling in a certain direction, and it has nothing to do with the point of the a certain point of mass in the wave. Next question is about the SHM. So you can try to help yourself to imagine by drawing, such a diagram with a simple spring and a mass that go back and forth with SHM motion. And so the idea that you should have known is when velocity is maximum is when the mass pass through the equilibrium. And so x is 0. Since it can go in this direction or the other direction, then you should have this point and this point. C could be correct, but the thing is it doesn't have a negative number, while B and D already you can see is wrong. And you could also consider that when x is at maximum, that means at the extreme position here and probably somewhere around here, then velocity will certainly be 0, and therefore the point that you have to pass through will be these 2 points. While for C, it would not make sense because it basically means when x is maximum, v will also be maximum in terms of magnitude, and therefore the answer would then be A only. Next question is about the phase change actually. So it's about the reflection and also the transmitted pulse. For transmitted pulse, you can imagine this is, or we can take it as refraction actually. And as in for refraction, you should actually know that no matter what the composition it is, whether it's thicker with the light one or the other way around, it would never has a phase change, so it would always be not inverted. As in for the reflector, it depends on whether it's heavy to light or light to heavy, like this case I draw here. So what you can do is maybe you can consider this case first. As I always tell my own student, that you can imagine the heavy rope is like the extreme case where it is like simply a wall that you have. And so if you try to make a pulse here, this point is basically like the fixed end. And in that case, if you have a light rope connected to a heavy rope, then what you get is when you go back, you have a inverted refracted pulse. And so in that case, it will be refracted. While if you have the situation that given by the question, you would not have any phase change. So the answer would then be D instead. Next question is actually not that difficult. First of all, you have to pay attention to the wording of ideal ammeter and ideal voltmeter. And what it means by this is the ammeter is 0 ohm, and while the voltmeter will be infinite ohm. And so if you try to think about this, these things are in series. So the equivalent resistance that you may have is simply infinite, because 0 plus 6 plus infinite. Again, this is not something that your math teacher will feel happy to, but we are learning physics, so let's take it this way. So basically, these will give you infinite. And in this case, since the V is finite, and so the current is basically 0. And when you consider V equals IR. At the same time, since you should know that when things are in series, the one with the higher resistance will take the higher amount of voltage out of it. And since 6 is basically insignificant compared with infinity, and so the voltmeter will take all the voltage, and therefore it will take 12 V. And so the answer would then be D. Or you can imagine this would take like 11.999 V instead, so basically 12 V. Next question. You should not overlook the fact that this time the voltmeter is not ideal and it has a resistance of 50k ohm instead of infinity. And so what you have to do is you have to calculate the equivalent resistance of the voltmeter, and this resistor is going to be 25k ohm. And among 25k ohm and 100k ohm, this one 25k ohm would take 25 over 125, and so that will be 1 over 5 times 5. That would mean it would take 1 V here. This question may give you a headache. However, if you could try to manipulate the dimensional analysis, that means by checking the unit, it wouldn't be that hard. So first of all, the definition of current is change of Q over change of T. And so the other thing that you want to pay attention is the question when they say how many electron is referring to the total number of electron, n, let's call it n. And so that would equal to Q over E. You may be thinking about probably whether or not it's this one or the lower one, n over E equal to Q instead. The better way of knowing this is by checking up the units once again. So first of all, you should know that the delta Q, the unit should be coulomb. And as in for the number of electron, the unit is actually like dimensionless. So when you try to check the E elementary charge itself, you can see that it is in a unit of C, coulomb also. So the one actually correct is this one, because the coulomb divided coulomb will give you a dimensionless unit. As in for this one, it wouldn't work because this one is dimensionless and while E is coulomb, so that wouldn't match with the right hand side because this is 1 over coulomb and this is in coulomb. So this equation is wrong while the upper one is correct one. By substituting this whole thing into this equation, then you can give I equal to big N times E over delta T. And if you try to check the question again, it said how many electron per second. So what you have to express is big N over delta T, and that would give I over E. And so the answer would be D. Topic 6 about circular motion. This question is asking you about the smallest kinetic energy that you need at point X. So what you have to think about is, in a circular motion, this is a vertical circle. The hardest part that you may not be able to maintain the circular motion is at the highest point here. And so what you have to consider is the circular motion at the highest point. And therefore, what you can think about is, at the highest point, you have the T tension here and the weight going downward, and they will act as the centripetal force, which equal to mv squared over r. And so in the worst case, where you have the V as minimum at the highest point, tension would be 0. So therefore, only weight is the one that helps you do circular motion. And if you rearrange the equation, you can get the minimum V you have at the top with the square will equal to the RW over M. With this idea, together with the idea of energy, GPE and KE at the top should equal to the KE at the bottom because of energy conservation. Then you can find out the KE at the bottom should equal to the GPE, which is mg2R, because this is 1R and this is the second R, plus the KE, which is half mv squared, and the V square is actually given from what we have done just now, and at the end you can get 5 over 2 times W and R, and therefore the answer is D. Okay, next question. Once again, this is about a vertical plane circular motion, and it said is at a constant speed. And so why is this so important? Is because when you have circular motion in a uniform speed, then F equals to mv squared over r has to be maintained. The F we referring here is the net force. That means the total amount of the sum of forces. And so when you consider, for example, when you have a mass at this point, which it must has a weight that pointing downward, then you have to think about with the tension itself, somehow there's a tension so that the resultant force has to be going along the rod, because once again, this is a uniform circular motion and therefore the force must be pointing towards the center. And in that case, if the net force is given like these towards the center, then the tension that you might have is probably something like this in that case. And therefore, for the answer, it would not be a constant, and it would be minimum at the bottom. Next question. First of all, you have to understand the definition of equilibrium very precisely. As you can see, it just simply appears in all the options here. So for equilibrium, if you simply search for the textbook or on the internet, you'll find out that would mean the net force would equal to 0. And according to Newton's second law, that means the acceleration is 0. And if acceleration is 0, that would mean velocity is constant. And so if you try to look at the motion here from x to y for a pendulum motion, for sure that's the direction has to be the tangential of the path. You can see it's kind of like a curve here. And so, and also not to mention the direction will be opposite when you go from x to y or y to x. Also, at the point of x and y, which is the extreme position, the direction is constantly changing, or you can imagine the magnitude is constantly changing, and that means at the end you will always have a non-constant velocity, and therefore the answer is D. This question is actually easy but tricky. You have to pay attention to the question that it said the different frequency will be produced. So according to the equation E equal to HF, for different frequency you must have a different energy. So here I'm talking about the energy change, of course. If you look at the energy level here, you will find out the combination of different transition could be 0.25 eV, 0.5 eV, 0.75, or 1.0 at most, as you can see from here. And so these are all the combination that you might have, unique number you could have. So therefore the answer is B only, instead of having 6. This question, actually I don't know why the percentage of this is so low. It's just very directly that you should have memorized, I would say, or understood that alpha and gamma are the discrete energy that you have, as in for beta, no matter it's plus or minus, and also the neutrino or antineutrino that it produces is always continuous. The idea of why it's continuous is actually due to the production itself. When you have alpha or gamma, that's the only thing that they produce, as in for beta and also the neutrino, then they may have a different combination of energy, and therefore because they produce the two things at the same time, therefore they are both continuous. This question, the first thing that I would recall after reading the question is basically this diagram. So if you can remember the binding energy per nucleon diagram, this is how the shape should look like. And in this question, it said doing the nuclear fission. Actually, it doesn't really matter. Even I think for fusion, it should work the same. But anyway, let's imagine you got the fission where you have, like, for example, like uranium, and then it gone through a nuclear fission process, and it get to Z and Y, and that should definitely something that it looks like here. And if you can recall the shape, then for sure that you know, no matter Y or Z, it must have a higher binding energy per nucleon than X, and therefore it must be greater than 1 for the ratio. And as in for the total binding energy, Y and Z must have a greater again, because per nucleon is the same. And when you try to add them up together with no matter how many number of nucleon numbers they have, cos it must be the same as the nucleon number of X, and therefore in that case it would also be higher than X, and therefore it is greater than 1 also. Once again, this question shouldn't be hard for you. One thing that you have to really understand is when we have the nuclear fission, well, you know, we are going to shoot a neutron to the, for example, uranium atom. And so the idea of having nuclear fission is not actually collide them to break them apart. What actually happens is the neutron get actually absorbed, so that it can become 236 uranium first, and then the atom get excited, and therefore it will split afterwards. The idea is a little bit like if you imagine the atom in itself is a magnet, and if you try to shoot an iron nail, because it's just magnetic as an example, if you shoot the iron nail too fast, too quickly, it can't pick up by the magnet. Only if you slow it down, somehow it might be able to get stuck with the magnet, and therefore the purpose of having the greater chance is actually by removing the kinetic energy from the neutron instead. To solve this question, there are 3 parts. The first part is by considering the definition of power. You have E over T, and the E referring is the KE, which is half mv squared, and then you can rearrange it to become m over T, because m over T is the mass per second, you can imagine, so which is somehow similar to this one, but pay attention, this is volume, not mass actually. As in for the v square, is not given, but this can be calculated by the conservation of energy, mgh equal to half mv square, and you can express v square equal to 2000. As in for the mass, you can consider the density equal to mass over volume, and you can just replace the m with rho density times the volume, and you just substitute everything in and you get the answer, and therefore it's D. To solve this question, you have to refer to the data booklets for 8.2. The first thing that you may want to look at is this equation, and basically you just have to substitute the wavelength into it, and you can get the temperature, which leads to 10 to the power of 3 K, and therefore statement 1 is correct. As in for statement 2, you just have to substitute this back to this equation for calculating the power, because this is basically talking about the power. And so if you try to do that, and together with this constant number, the Stefan-Boltzmann constant, you can also get the number of this. And as in for number 3, because it said it's a perfect absorber for this, basically is talking about black body. So the answer will be D. In this question, probably quite many of the students were tricked, because when they do this question, they just look at the equation given from the data booklet and has no understanding towards the equation itself. So to do this, what you have to understand is the equation given here is actually derived by the elastic potential energy. E total energy equals to 1/2 Ka, or some people may use x log square, the amplitude square, for an XHM motion. And the reason why you may have done it wrong is because you thought you can just look at this equation, and by assuming omega is actually constant, but in fact it is not actually a constant during the change here by changing the mass. And so what you can do actually is by thinking about the you can try to derive the equation again by using F equals ma equal to the tension kx. You can get the omega square actually equal to k over m. And so in this case, you can see the changes between omega and m. More simply, without considering this, you just have to consider this equation directly, and by realizing K is actually not changing because you are using the same spring. The mass for the equation is actually independent, and so if you only change the amplitude x log, or you call it A, then you're only changing this number. And if you have 2A for the change, then that means you substitute 2A into it, and that means it will become 4 times greater because there's a square here. So the answer is actually B. Again, I don't know why this is a very low correct rate, but apparently this is a single slit situation, and therefore you are going to use this equation. It said the width is now reduced, and therefore B in this equation is talking about the width, the slit width. And if this get reduced, the only thing that got changed is the angle, which is referring to the first minimum, would increase, while the wavelength of course is the same, like so same. From the answers, as you can see, D will be correct answer because apparently the angle got increased. Pay attention that the original pattern is in dotted line, so you can see the original is closer to 0. The solid one, the new one, actually got further, so it increased. Then you may ask, so what about this one then? So the difference between A and D is the intensity, whether it got lower or maintained the same. The answer would be the same for D, because you just simply imagine if you have a laser going through this slit. If the slits get really small, barely like completely blocked, and for sure that the intensity will get lower and lower and lower. Next question, when you see the total energy is 16 and it said what's the KE when it is at half of the displacement, what you have to do is simply refer to the equation once again. Again, like the previous question, I don't actually like to use mass omega square. I prefer to use K instead, because again, K, when you have the same spring, it doesn't change because it's a constant for the same spring. And so you can use this equation, x log square minus the new displacement, which is x log over 2, and so you simply just get the answer 12 in a very secure way. For this question, the main issue that people usually face is actually reading the question. The question is saying 3 out above the surface of the planet. So actually, the distance that you should set into the equation for no matter this one or this one is actually 4 out instead. And so in that case, it will lead to the answer of A instead. This question is asking a concept that people usually find confusing. So basically, you have to recall the energy for an orbiting object. For example, a satellite, for its KE, GPE, and total energy. And this is something that you can find from the textbook. For GPE is defined this way. KE you can derive using the circular motion, and therefore, if you add them together, you get this. As in for the expression, with the change here, low orbit to a high orbit, that means the R radius get increased. And so what you have to look at is basically for all the R. And so these R get increase. And so in this case, this total energy becomes less negative. As you can see with the bigger R, that means the whole number get smaller, so less negative. Less negative means it has more energy, so total energy actually increase. As in for potential energy, these get smaller once again, so again it become less negative, and so total GPE actually increase. As in for KE, you can see the number which is positive get smaller, and so not as that positive, and that means it decrease. And so this is something that you just have to find. Increase for total, increase for GPE, and decrease for KE. So the answer is D. Next question. The first thing that you may want to understand is the area, because the answer provided here, including S is the shaded area. The area in itself in physics is actually meaningless, because you just can't find any physical quantity to describe what it is for integrating the gravitational potential with respect to distance. The only thing that you may find is the difference between the V, which can give you a difference of gravitational potential, or not for this question, but in general, the slope of this, which is dV over dr, with the negative, is actually the gravitational field strength, E. But in this question, it's not actually relevant. The idea that you need to understand is when you have a planet, for example, Earth here, and if you want to send an object towards or away from the Earth towards the infinity, for sure that it's like launching a rocket. You have to give energy to it. And if you have an object that is going down to the Earth by gravitational force itself, the object is gaining energy. The question states that the work done by the gravitational force. So you have to be really careful. The work done by the gravitational force when you are moving from the surface to a further away distance. So it's more like this one. So moving away from the Earth. So what you can imagine is if you have an object that is moving closer to the Earth, you are doing a positive work done by the gravitational force, because it's just more like naturally the gravitational force will pull you towards the Earth. But now what you're doing is more like, I would say, unnatural to the gravitational force. It's more like against the gravitational force. And therefore, the work done that you should have at the end, again by the gravitational force, should be negative instead. And so if you try to look at the answer, you need to obtain a negative answer, and therefore you must have to get a more negative number minus the less negative number, and therefore the answer is B. In this question, notice that this is a power against time graph for a generator. Since it said the power being produced, so for sure it has to be a generator. And consider the typical generator that you have. The V that you produce is more like AC, and so the waveform you can see from here is more like simply like a sine wave. When you're calculating the power in general is V squared over R, so you have to do the V squared. And therefore in this diagram, it looks more like a square of sine wave, and more importantly, you do not have the negative area. As you could imagine, it might be like this, but actually this doesn't exist because it would definitely be positive when you have the square. And so for an actual cycle that you should have, it's actually start from, let's say 0, it would end at 10 instead of 5. So this is one cycle instead, because you can see this is actually one cycle. And so for the period, the period will be 10 milliseconds. As in for the power, you just have to refer to the data booklet. And for the data booklet, it said for the maximum power is equal to I log V log, and most importantly, maximum power, as you can see from this diagram, it is 120. And if you want to calculate the average power, because that's what the question asks, average power, with that bar here means average, will equal to half of this I log V log. And so half of 120 is gonna be 60, and so the answer is B. This question I feel is more like a trolling question, because you may feel that it might be something like this, but in fact you may find out the B field actually cannot be cut by the area, because the area are always going to be parallel no matter how you turn it or which position that it is having. It's always parallel to the B field that you have. Then you may wonder, so how can this be a generator? That's the same thing that I'm thinking. The normal generator that you may find anywhere on Google or on your textbook looks something like this. So the B field go like this, and when you turn this, you can see that it can get to going through to the coil of this. While this one, you can actually never have it. And imagine how could you possibly get the wire I mean, it's just not possible. So the answer is actually A, 0. First of all, you have to find the definition of capacitance from the formula booklet, or you can just recall it. It's Q over V, charge over voltage. And the second thing that you want to recall is the 7 fundamental units, which is kg, meter, second, Kelvin, mole, candela, and amperes. And then with the help of these two equations, I equals to charge over time, Q over time, voltage equal to energy over charge, then you can convert into this equation with the help of work done, which is F times D, and F is net force, which equals to MA, and so you can get this equation. And so by considering each of these variables, you should have very familiar with each of them. You can just convert into all these units, and then you just simplify it, and therefore you can find the answer as A. You just have to do it carefully. Okay, this one is a little bit complicated. So from the question you can see it said for electric effect you have the same intensity but higher frequency. So let's talk about the general idea first. If let's say there's another situation where you might have a high intensity with the same frequency, according to the general idea, or even like the textbook, you will find according to the particle view, we will have more number of photons with the same energy, because frequency is related to the energy by using the E equals HF equation. This is true, but of course, the question now is saying is the same intensity but higher frequency. So what you have to consider is the I is being the same but frequency being higher. The result would be having, of course, for each energy, each photon energy, it will be higher, once again because of this equation. However, due to this, we will have also due to the same intensity, we will have less number of photons. The idea behind is more fundamentally by considering intensity equal to power over area with the same power, because the question didn't say you change the light or anything, so the power must stay the same, and therefore intensity must stay the same also. Then you can imagine the energy per second or per unit area, it will be the same. So imagine you have $1,000, you are giving it away to different people. What you have is at the beginning you have each giving like $10 is like having each photon with less energy. You can give away for 100 people, and when you have each photon carrying more energy, it's like you are giving out money with greater amount. So let's say $20 for each, and therefore you can only cater for 50, and therefore you can have only 50 photons. It means you have less photons in total because of, again, energy conservation, and therefore the answer would be less emission, so lower. This question, when I look up into it for the first place, I also get quite confused. The idea is it has to be a very long half-life of radioactive substance. You may imagine is carbon-14. For information, carbon-14 has 5,700 years of half-life roughly, and therefore if you think about waiting for the half-life, is actually impossible until I don't know, your next generation. You still can't see for a whole half-life cycle, and therefore you can imagine the change over maybe let's say 10 years is very little. So what you have to think about instead is by looking at the formula, you can remember that the activity equals to dN over dt. And so with the given condition, the initial activity of the sample, that means you can substitute T as 0 into this equation, and therefore you can have A log, which is the initial activity, equal to lambda n log e to the power of 0, and apparently this is actually 1, and that means you can derive this equation. And as in for the so-called half-life you want to measure, you are actually finding out lambda, which means this one, and since you know A log, then what you just have to know is n log only, and therefore the answer is D. You just have to know the mass of the sample. Okay, finally the last question. I hope you can get it correct. So for this question, what you have to consider is the equation from the data booklet, this one, and this is describing the relationship between the radius of a nucleus to the mass number. For the R log is more like a constant called the Fermi radius. It's just a constant. You probably don't need to care about it. And so what you have to do is to list out the condition or the equations where for silver 108, it will have this equation, and as in for the one that is the unknown, I use x to represent, and so Rx, radius of x, equal to R log x to the power of 1 over 3. And since the question says it's approximately 3 times, and surely you just have to use the ratio to calculate, which is 3 to 1, so 3. And then on the right hand side of this equation, you just have to make a fraction here, and R log got cancelled out, and you just solve the rest, and you will be able to find the answer to be A at the end. That's all for the questions. Let me know in the comment section how many questions you get it correct, and also if you have any harder MC questions from the IB physics past paper, let us know in the comment as well.